Welcome to today's session. So today we are going to discuss the combinations, and in the last class we discussed about the permutations. Now we are going to define what is the difference between permutations and combinations, and I am going to explain some of the problems related to the combinations. Okay, now see, permutation, we know number of permutations when R elements are arranged to be. That means that there are total n number and number of elements. In that R elements that we are going to arrange, then that is NPR. That is n factorial by n minus R factorial. Let us consider the n is equals to 4. I am just taking. So that is A, B, C, and D. Then R is equals to 2. That means the permutation size is equals to 2. Then the number of permutations is nothing but 4p2. 4p2. They are 12. They are 12. So the 12 permutation, what are those 12 permutations are? AB, BA, AC, CA, and AD, and DA, DA, and BC, and CB, DB, BD, and next. So these are the CD, and next DC. Okay, these are the different 12 permutations will have. Now let us concentrate the combinations. See, what is the combinations? Same thing. We are going to take n is equals to 2. That means it is different from the selection of a given number of elements taken by one or some or all at a time. Suppose, for example, if you want to consider two elements A, B, then there is only one way to select them. That means either we can select A first and B next, or B first and A next. So both we are going to combine as only one. Then we select both of them. The number of combinations when R elements are selected out of any elements is NCR. That is n factorial by R factorial into n minus R factorial. Now let us apply the same previous problem to these combinations. N is equals to 4 we have to consider, and R is equals to 2 if you are going to consider. Then how many combinations I am going to get? There are 6 combinations. So what are those 6 combinations? See, earlier the permutations are AB and BA taken as 2, then they are going to consider as AB only. AB only. So now AC and CA will be considered as 2 there in permutation, whereas a combination that is equals to AC or CA, whatever it is. That means the total number of permutations, total number of combinations, whatever the permutations we are going to get by 2 we are going to get here. So that is nothing but 6 combinations we are going to get. So these are the 6 combinations, whereas these are the 12 permutations. 12 permutations. So here in the permutation, AB and BA are 2 different things, whereas in the combination, AB and BA both are same. AB and BA are same. Now let us concentrate some of the problems on these combinations. Out of 7 consonants, so there are 7 consonants will be there, and 4 vowels will be there. 4 vowels will be there. Now the question is, how many words of 3 consonants? How many words of 3 consonants and 2 vowels are formed? 2 vowels are formed. So here, that means there are 7 consonants will be there. So from 7 consonants, how many ways that we are going to select? 3 consonants. So that is 7C3 ways we are going to consider. So the first task is selecting the consonants, and the second task is selecting the vowels. So next one after the other. That means this is a product rule. Then we are going to apply. Now there are 4 consonant vowels will be there. Out of 4 vowels, 2 vowels we have to select. How many ways that we are going to select 2 vowels out of 4 is 4C2. 4C2. Now we have to select. Task 1 is this and task 2 is this. So these are 2 tasks that we are going to perform one after the other. So that means the number of ways that we are going to select 3 consonants from 7 and 2 vowels from 4 vowels. That is nothing but just a product rule we are going to apply. So finally we are going to get to 10. But the thing is here, in the 10 groups will be there. Among these 2 groups, and there are 5 elements will be there. So 5 elements can be arranged among themselves in 5 factorial ways. So 5 factorial is again we are going to get 120. Again we are going to have 120. So total in each group. So that means there are 120 arrangements will be there. There are 10 groups will be there. So what is the required number of ways that we are going to arrange? So it is nothing but 210 into 120. For each group, it is 120 ways we are going to arrange 5 letters among themselves. So there are 210 groups will be there. So 210 into 120. So subsequently, this we are going to get this number of ways that we are going to select 5 number. We have to select the 5 elements, 5 letters. That means either they are 4 consonants and next 4 vowels and this is 4 consonants and 2 vowels. That we have to select this. Okay, so that means 3 consonants and next 2 vowels that we are going to select. Total is 5 and the next 5 is among themselves 5 factorial, and then this is the number of groups that we are going to get to 210. So now let us go for the other example. In the group of 6 boys and 4 girls. 6 boys and 4 girls. Now we have to select 4 children among them. 4 children among them. So the question is, in how many different ways can they be selected such that at least 1 boy should be there. At least 1 boy should be there. So there are 10 members will be there, and out of which we have to select 4. We have to select 4. The condition is, so how many ways that we are going to select 4? The condition is at least these 4, there is at least 1 boy should be there. 1 boy should be there. So at least 1 boy means, so the group is consisting, then we can select 1 boy, or we can select 2 boys, we can select 3 boys, and we can select 4 boys. There are 4 different options will be there. The first option is we can select 4 boys. So there are total how many are there? 6 and boys will be there and 4 girls will be there. So there are total 5 and there are total 10. Among these 10, 4 we have to select. All the 4 may be boys and 3 boys may be there and 1 girl will be there and 2 boys will be there and 1 girl will be there, 1 boy will be there, 4 girls, 3 girls will be there. So these are the different combinations. That means 4 we have to take. So all 4 are boys. All 4 are boys. Or else if I am taking, so 3 boys and 1 girl. 3 boy and 1 girl. Or I can take it as 2 boys and 2 girls. 2 girls. And the next another one is 1 boy and the next 3 girls. 3 girls. So these are the 4 members I am going to select. All 4 are boys, 3 are boys, 2 are boys, like this. These are the 4. Now, here what is the question is, how many boys will be there? How many boys will be there? There are 6 boys will be there. 6 boys will be there. And the next another one is 4 girls will be there. So 4 girls will be there. Now the thing is, from the 6 boys, how many ways that we are going to select 4 boys? How many ways that we are going to select 4 boys? So that is 6C4. 6C4 ways. And now the second one is, this is the first one. If I am selecting all the 4 boys, all children are boys, then it is, there are only 6 boys will be there. Then out of 6, we have to select 4. So 6 4 ways. And now the second concept, that means here the first one is 6C4. And whereas if you are going to consider the second one is, so 3 boys we have to select out of 6. So it is nothing but 6C3. 6C3. And the next another one is 6C3. And the next what I am going to select? one is going to be girl. One is going to be girl. So here, out of how many girls are there? Only 4 girls are there. So then it is 4C1. 4C1. So 3 boys are selected. This is one task. After that, we are going to select the girl. So that is the product rule. And for this, if I am going to take this 6C2 and into 4C2. So next, if I am going to consider 6C1 into 4C3. 4C3. So 4 children that we have to select, but the condition is the 4 children, one should be boy, at least one should be boy. So boys are going to be increased. Then these are the total number of ways. So what is the total number of ways? This is the first choice, plus this is the second choice, plus this is the third choice, plus this is the fourth one. So we are going to add all the things. Subsequently, we can get this as the final answer as like this. So 4C2, 4C4, that means so 6 factorial, 6C4, that is nothing but 6 factorial by 6 minus 4 factorial into 4 factorial. So by using this, so what is this? 6 into 5 into 4 factorial by 4 factorial into 2 factorial. These two get cancelled. 2 3s are. So subsequently I am going to get 15. So this is 15. And like that, the remaining also have to calculate. We have to calculate 463 and 463. It is 6C3, 6 factorial by 3 factorial into 3 factorial. So now this is 6 into 5 into 4 into 3 factorial by 3 factorial into 3 factorial. So these two get cancelled. Now this is get cancelled. It is 20. It is 20. So for this I am going to get 20. This I am going to get 20. 4C1. So 4C1 is 4 factorial by 3 factorial into 1 factorial. It is nothing but 4. So it is nothing but 4. So I am going to get 20 into 4. So it is nothing but 80. It is nothing but 80. Like that, if you are going to perform, finally we are going to get these are the total number of ways that one should select. One should select. The group is consisting at least one by. Okay. Now go for the next one. A group from a group of 7 men and 6 women. 7 men will be there and 6 women, which is similar to the above problem. And the thing is, so here let us say, and this is we have to consider 7 men and the next another one is 6 women. 7 men and 6 women are there. Now 5 persons has to be selected. 5 persons has to be selected. Which at least 3 men. Okay, that's all. 5 persons are to be selected to form a committee so that at least 3 men are there in the committee. So 5 members will have to consider a committee from 7 men and 6 women. In that, at least 3 men should be there. The committee size will be 5. So what I am saying that at least 3 means 3 men plus 2 women. And this is the first possibility. Second possibility is 4 men and next 1 woman. And the third possibility is 5 men and there is no woman. So these are the 3 possibilities will be there. 3 options we have. So first options are, so we have to say that there are 3 men and 2 women, and there are 4 men and 1 woman. There are 5 men. There are 5 men. See here, this how many ways I am going to select. The first option is 7C3, right? 7C3 and 2 women out of 6. So into 6C2. And next plus the second option 7C4 into 6C1 and another one is 7C5. So these are the total number of ways that one should perform a committee which is having at least 3 men. So that is given here. So which is okay, of course, option 1 is all are men, and option 2 is 4 men and 1 woman, and option 3 is 3 men and 2 women. 2 women. Finally, we are going to get these number of ways that we have to select, and final total number of ways are just adding all the things. Subsequently, we can get the final result. Now, the another problem in a question paper, there are containing 2 different parts, part A and part B. Each containing, part A contains 4 questions, part B contains 4 questions. Now the thing is, how many different ways a student can answer 5 questions? A student can answer 5 questions by selecting at least 2 questions from each part. At least 2 questions. So either this one you have to select 2, this one you have to select 3. The remaining one, then we have to consider either here or here. So first of all, let us consider first choice is 3 here and 2 here. And the second choice is 2 here and 3 here. So this is the restriction, this is the condition. So now student can answer 3 questions from part A and 2 questions from part B, or else student can answer 2 questions from part A, 3 questions from part B. So here, how many total questions are there? 4 questions. So we can write it as 4C3 into 4C2 for this option. And for this option, we are going to get 4C2 into 4C3. So now we are going to get like this. So 4C2 is equals to 4 factorial by 3 factorial into 1 factorial into, then the remaining is 4C2 is 1 factorial, then it is 4 factorial by 2 factorial n minus r, 4 minus 2 factorial into 2 factorial. Subsequently, we can have first one is 4 and the second one is 4 into 3 into 2 factorial, and of course it is 2 factorial and this is 2 factorial. Get cancel, then it is a 6. We are going to get 2 2s are. So it is a 4 into 6. So it is nothing but 24 ways. So first one is 24 and the second one is 24. Then the total number of ways is 24 plus 24. That means this plus this we have to add. Then the total number of ways the student can answer 5 questions are 24 plus 24. These many ways that one should answer the question. Now, let us go for the same thing. A question paper is consisting 3 parts, A, B, and C. And now, 5 questions, see, a certain question paper contains 3 parts with 4 questions. In part A, then 4 questions in part A, and next 5 questions in part B, and see, this is 5 questions in part B, and then this is 5 questions in part B, 6 questions in part C. It is required to answer 7 questions. By selecting at least 2 questions from each part. 2 questions from each part. So now the thing is, either the choices are, either he can select, these are 6 questions. So either the first choice is 3 questions, 2 questions, 2 questions. Or else 2 questions, here 3 questions, here 2 questions. Or else 2 questions, 2 questions, 3 questions. So total, we are going to get all the 3 are 7 questions. 7 questions we are going to get. So now, this is, we have to select 3 questions. Student has to select 3 questions out of 4. So that means what we are going to get? 4C3. The first one is, we are going to get 4C3 into, and the next, the second one is, this is into, he has to answer and 2 questions from part B. So while answering the first 3 questions from part A and next 2 questions in part B. So out of 5, he has to select 2 questions. After that, he has to select 2 questions from part C. So 6 questions are there, total number of. So these many ways he can select the first one. He can select the first one. And he can select the second choice. It is 4C2 into 5C3 into 6C2. This is the second choice. These many ways. And the third choice, 4C2 into 5C2 into 6C3 into 6C3. These are many ways that he can select the choices. So what is the total number of ways? Just we have to add all the 3. We have to add all the 3. Subsequently, we can get the 2,700 possible ways he can select. He can select whatever the conditions are given. According to the condition, he can select the questions. He can select the questions. So this is the way that he is going to select the questions. Now, let us go for the another example. So here there are 11. A woman has to invite 11 close relatives. A woman is having 11 close relatives, and she wishes to invite only 5 of them to dinner. And she is interested to invite only 5 members out of 11. In how many ways she can invite them in the following situations? So the first one is, there is no restriction on the choice. That means she can select any 5. And she can invite. And the second one is, 2 particular persons will not attend separately. So 2 particular persons, they will come together or they will not come together. So woman is having a choice to call both of them to the party, or she is not invited both of them. That is the case that is going to be occurred. And here the third case, the 2 particular persons will not attend together. So here the second one is, they are going to attend, 2 people are going to be attend together, and here one X is going to be attended, Y will not be attended. Y will be attended, X is not attended. Then the 2 persons, if you are going to consider as X and Y, if X will come, Y will not come. Y will come, X will not come. And the woman is having 3 choices. Whether she invites first X, or she invites Y and she won't invite X, and she does not invite both. So these are the 3 possible combinations that a woman is having for this particular situation. Now the question is, now we have to consider all the things into the restrictions into the consideration, and we have to find out how many possible ways. So there are 11 members, 11 close relatives are there. So if there is no restriction, in how many ways she can invite is, the first one is 11C5 ways. 11C5 ways that she can invite. So that is nothing but 11 factorial into 11 minus 5 factorial into 5 factorial. So by using that, and if you are going to simplify, then we are going to get 462. Now the second one, if you are going to consider, 2 particular persons will not attend. 2 particular persons will not attend separately. Let us consider X, Y. The 2 particular candidates are X and Y. They are not attended separately. They will come together or they will not come together. So the first case, woman is having, she invite both of them, and she does not invite both of them. does not invite both of them. Suppose she invites both of them, then she has to select only 3 remaining. So these 2 people will come and she has to select only remaining 3. So 2 people already selected means 11 minus 2, that is the total number of people are only 9. So from the 9 people, she has to invite 3 among them. So how many ways? 9 C3 ways. So this is the first particular case. That means she is going to invite both of them. So how many ways? 9 C3 ways. Because already 2 are invited. Subsequently, the remaining relatives are 11 minus 2. There are only 9 relatives are there. So out of 9, she has to select only 3. So 9 C3 ways. So she invites. Suppose she does not invite, this particular case if you are going to consider. So she does not invite means, that means we are not going to consider the X and Y. She is not going to call. So the remaining, how many are there? 9 members are there. So from the 9 members, she has to invite 5 members. She has to invite 5 members. So subsequently, whenever does not invite case, then she has choice as 9C5 ways. 9C5 ways is nothing but 126 ways. 9 factorial by 9 minus 5 factorial into 5 factorial. If you are going to simplify that, we are going to get 126. So the thing is, whether she invites one case, she does not invite those 2 people. So what are the total possible ways? That means we are going to add these 2. So we are going to add these 2. So if she invites both of them and if she does not invite both of them, the total number of possible ways. So just simply we are going to add these 2. 84 plus 126 taken together as 210 ways. Now this is the second problem. And now whereas the third problem, if I am going to consider, so here 2 particular persons. So here X, Y, they are not. Whenever X comes to the party and Y will not come. And when Y will come to the party, X will not come. So she is going to invite, either X is invited and Y is not going to be invited. And next, if Y is going to be invited, and next X is not going to be invited. And the other thing is, she is not going to be invited both. So here, the first one is, I am just considering, see here, there are 2 persons. If I am going to consider 2 persons, X and Y, I am going to remove 2 persons from the total close relatives, 9 members. There are 9 members. Why I am removing? Because I invited X, assume that Y is not going to be attended. So these taken 2 members are together. If I am going to consider Y and X will not attend, so I am going to invite only one person and other person treating with the condition the other person will not come. So I am going to reduce 2 members. So finally I am going to have only 9 members. So 9 out of 9, I have to select 4. Because X is invited. 9C4. Y automatically is not going to be attended. And the second possible case is Y is invited. So that is nothing but 9C4 ways. Automatically X is not invited. X will not come. Then the other case is both are not invited. So both are not invited means the remaining how many I can select? I can select 2 members. to the party. So this is if X is invited, of course Y is not attended. And this is Y invited, but X will not be attended. So remaining I have to select only 4. And here both are not invited. Then I have to get 9C 5 ways. So then if I am going to simplify all the things, so it is 126, this is 126, and see, all I am getting the same. 9C 5. So if I am going to add all the things, so I am going to get the final answer. Final way I am going to get so what about 9C 5? 9 factorial by 9 minus 5 factorial into 5 factorial. So 9 into 8 into 7 into 6 into 5 factorial by 5 factorial, and of course 4 factorial into 5 factorial will both get cancelled. Then it is 4 into 3 into 2. So it is 24. 24 means, so I can 4 into 3 into 2. So 2 3s are, then 4 2s are, then 3 3s are. So what I am going to get, this is 9, 18, 9 into 2, 9 into 2, 18 into 7. So this is 126. What about 9C4? 9C4, okay. 9C4 and 9C5, both are going to give it the same. So subsequently, we can get how this is the final answer. So now, let us go for the other one. From this is a similar earlier problem will be there. From 7 consonants and 5 vowels. This is already over. And now, now find the number of arrangements. The letters are given which have no adjacent ears. So adjacent ears will not be occur. Now here, how many are there in this? So how many letters are going to be repeated? So here there are total 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. Now, out of which, how many A's will be there? A's are 3 will be there. And U's are, what about this? LLA, HA, SSEE. So if I am taking E is only 2. And now, then what about A's are? A's 1, 2, 3. A's are 3. L's are 2. S are 2. And of course T 1 and H is 1. This is 5, 9, 10, 11. 11 letters are going to be arranged. Now the thing is, there is no adjacent A's. So I am going to remove these A's. So there are 3 A's out of 11. So 11 minus 3, subsequently 8 letters I am going to get. So I am not going to consider any of A's. So now there are 8. I am going to consider 8 letters. So n factorial, that is, let us consider, regard or discard all A's. Then what I am going to get? 8 factorial. Then by, this is repeated twice, this is repeated twice, and this is repeated twice. So 2 factorial, 2 factorial, 2 factorial. Then the remaining is 1 factorial. So which is nothing but 5040 ways. So 5040 ways, let us, I am just taking. So if I am not going to be considered, so here 8 letters, what I am taking? T, A, L, L, H, and next S, S, E, E. So I am going to consider either I can keep here, or 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 I can keep here. 1, 2, 3, 4, 5, 6, 7, 8, or 9. So here, what about this? I have 9 positions will be there, 9 locations will be there. then I am going to keep those 3 A's. Subsequently, there is no adjacent A's will have. So here, how many possible? This is 9 places will be there. Out of 9 places, and I have to accommodate 3. How many ways? 9C3 ways. 9C3 ways. So one is the total number of arrangements here without having A, and the 9C3 ways I can incorporate A's after the letters in such a way that there is no 3 A's should be adjacent. A should be adjacent. So that is the second task. This is the second task and this is the first task. So this is 5040 into 9C3. So that is nothing but these are the total number of ways. Total number of ways one should get this. That means find the number of arrangements of the letters in the word which have no adjacent A's, Now, let us go for this. See here from 7 consonant and 5 vowels, let us say 7 consonant and 5 vowels and 4 consonant. See how many ways, how many sets consisting 4 different consonants and 3 different vowels I am going to form. So here, what is the thing is 7C4 and next 5C3, 7C4, 5C3 ways. That means I am going to get for each group I am having like this. Then there are among these 7 letters, there are 7 factorial ways I can accommodate so that the total number, there are 3 tasks will be there, 1, 2, 3, 1, 2, 3. So for each group, 7 factorial will be there. So there are these many combinations I am going to get. So this is nothing but multiplied with each other. Subsequently, we can get this is 17,64,000 I'm going to get. And now, let us go for the binomial and multinomial theorems. What is a binomial theorem? What is a binomial theorem? So here, we know if the function will have any 2 variables, so then I am going to consider nc0, x to the power of n, x to the power of r, and y to the power of n minus r. If I am taking 0, then I am going to take it as x power 0, n minus 0, plus nc1, x power 1, y power n minus 1, plus nc2, x square, y power n minus 2, plus and so on, plus ncn, x to the power of n, y to the power of n minus n. So this is the expression. This is the expression. Now, so I am going to write the whole thing into a summation notation. Let us assume that this I am going to write ncr, x to the power of r, y to the power of n minus r. R is equals to 0 to n. R is equals to 0 to n. The summation is going to be varying. This is r equals to 0 to n. So this is known as a binomial theorem. So for the positive integral index, and the numbers are NCR, whatever the coefficients, if I am going to consider NCR, that is for r is equals to 0, 1, 2, 3 and so on. These are all known as binomial coefficients. So this is NCR. So NC0, NC1, NC2 and so on. NCN, these are known as binomial coefficients. Binomial coefficients. Now, if I am going to expand, this is only for a function of 2 variables. These are 2 variables, so it is having. Now, suppose if it is having n variables, let us take x1, x2 and x3 and so on, xn. They are n variables. If they are having n variables, then the coefficient of x1 to the power of n1, x2 to the power of n2 and so on, x3 to the power of n2 in this expansion is nothing but n factorial by n1 factorial, into n2 factorial into n3 factorial and so on into nt factorial. Nt factorial with the condition that n1, n2 and so on nt is equals to n, and each n, ni, n1, n2, n3 and so on, 1, 2, 3 and so on is a non-negative integer. Non-negative integer, of course it is less than n. Of course it is less than n. So this is known as a multinomial theorem. Multinomial theorem. Now, in the next class, we are going to discuss, we are going to prove this, and we can consider if it is having more than two variables, and of course, this is known as whatever this NC0 is known as a binomial coefficient, and this is known as a multinomial coefficients. And in the next class, we are going to discuss, we are going to prove this, and we are going to solve some of the problems related to the binomial or multinomial theorems. Okay, so thank you.
Like, share and subscribe. Hit the bell icon for more updates.